Okay, so the last video you saw, we were actually setting up this whole project. And the project is essentially the computer's going to think of a number between like 1 and 10. And then you will try to guess it, and then the computer will figure out whether you're too high or too low, and then it'll give you feedback, and then you can keep guessing until you get it right. So we pseudocoded in English what we wanted to do, and now we're going to actually make that happen. So in this case, we want to create a random number, and then we want to save it into a variable called answer. And answer is essentially going to be what the computer is going to compare your guess to. And what we've done in the driver is the driver creates a new instance of the GuessNumber class, and then it calls play. So we can assume that every time you run GuessNumber driver, it's going to play one game. And everything inside this play method it should handle, everything about the game. So what we'll do is we're going to create a variable that will hold the value of the answer. Now, most of the time, classes are described, they're organized in this way. You're going to have essentially your instance variables up here. And the rule about where variables are visible is variables are always visible within the braces where they're declared. So if I declared the variable here, if I said int answer, that will not be visible to any other method outside of play, because here's its opening brace, here's its closed brace. It's only visible within this area. Now, for our purposes, that's appropriate, because there is no other method. We know there's going to be no other method, and it's all going to be sort of self-contained within play. When play exits, the game exits. But as a matter of practice, it would make sense to declare it outside of the play variable. Outside of the play method. Because if we declare it out here, it's still going to be accessible within play. And it's going to be also accessible if we ever wanted to use it anywhere else. Like, let's say we wanted to have another method that checks answer and just double checks it and makes sure that it's not something bizarre. I don't know. But as a matter of practice, you normally would declare your instance variables at the top of your class outside of all of your methods. Now, the value of answer is going to stay consistent. So between times that we call the play, if we were to call play multiple times, the value of answer would not change from the last time play was called. So if we generated a random number here, then every time you called play, the answer would always be the same, unless you sort of gave it a new value somewhere else. But that's not really an issue for us because we're just calling play once. So again, anyway, just some things to be aware of. Where you declare the variable affects its scope, where it is valid. So let's go ahead and initialize. We're going to declare our answer. And we're going to change this to let's just initialize it to 0, at least initially. Okay, so we've declared it and we've initialized it. Okay, and let's also declare our guess too. Let's say int guess equals 0. Now, we're going to have the computer guess a number between 1 and 10. But initially with guess equals 0, that'll help us kick off our while loop, and you'll see why a little bit later on. So we've essentially created a random number for the answer. We've created a variable to keep track of whether the game is won or not. Oh, we haven't done that yet. Let's do that. Let's create a Boolean variable, game1, and we'll call it false right now. Because the first time it runs, it's false. So, okay. So I think we're all good. Now we're going to ask the player to guess while the player has not guessed it correctly. So within the play method, what we're going to want to do is we're going to want to set up what's called a while loop. And a while loop says while what's in between these parentheses evaluates to true. So this needs to be an expression that evaluates to true, like if this is greater than that, if game1 equals false, those kinds of things. But as long as it evaluates this to true, then it's going to do whatever's in the brackets. So that's the format for a while loop. While, and then something in the parentheses, and then the braces. So what's the condition that we want this to continue to do, the stuff in the loop? during. We want it to continue to do it as long as you haven't won the game yet. In other words, as long as your guess doesn't equal the answer. So we'll just say while game1 equals false. If we made a mistake and said if game1 equals false, single equals sign, then every single time it evaluates this, it's going to set game1 equal to false, and you will have a never-ending loop. So it'll never get out of this while loop. But that's a common mistake. We want two equal signs. So as long as we haven't won the game yet, what do we want it to do? We want it to, let me check my notes here. We want it to ask the player to guess. So let's just say system.out.println. What do we want to say? Guess a number between 1 and 10. Actually, let's do this, and that way it will just show up next to it. Okay? And then what we want to do is we want to take in an int variable, and you recall from your last lab, all we need to do is say guess equals. Usually we would say int guess, we would just declare it and then assign it a value, but because we've declared guess outside of the play method in our instance variables, we just say guess. We don't redeclare it. So guess already exists, so we just say guess takes the value of, well, we have to initialize our scanner first, I guess. Let's go ahead and do that. Scanner KB takes the value of new scanner, new scanner system.in. You really don't need to know this by heart. Just look it up on a previous assignment. So guess equals KB dot next int. If you didn't remember what this was or how to spell it, you could always go into Google and type in Java docs and then scanner, and then it'll give you all of the information about what the methods are that scanner knows. Okay? All right. So now we've got something called guess. Now what we want to do is we want it to say if the guess is greater than the answer, say too high. Okay, so we can do that. So we'll just say if guess is greater than answer. We want it to, and then notice I hit enter, it indents it. I'm just going to put this inside of brackets anyway. System.out.println too high. And then close off our braces. The next thing we need to do is say, if the guess is lower than the answer, say too low. So if guess is lower than the answer, open braces, system.out.println too low. And now here's where I was talking about in the last video. If it's not too high and it's not too low, we know that it is, like Goldilocks would say, just right. You guessed it. There is no other option, right? If it's not too high or not too low, it has to be it. So we're going to say else system.out.println again. I probably should have just copied that so I could just paste it in from the clipboard. You guessed it. And the other thing we need to do, we need to not forget to do this, is and say that the guess is the same, so we exit the loop. That doesn't really make sense. Say that the game is won, really. That makes more sense. So how do we do that? How do we do that? We just say game 1 takes the value of true. Boom. As soon as we do that, now it's going to evaluate it. It's going to say, okay, game 1 is no longer false. It's true, so it won't run anything, and it'll just exit the game. So we will win at that point. And then let's just make sure that all of our braces are matching, and I think they are. And then we'll go ahead and save it and run it, and we'll get an error, and then we'll just debug it and figure it out. Oh, it actually ran the first time. Amazing. Okay, so now let's go ahead and run it. Okay, guess a number. Oh, wait a second. We forgot to assign a random number. It's 0, isn't it? Yes. Okay, I'm amazing. All right, so let's go ahead and do that one thing. That's a bug. That's called a runtime. That's called a runtime error as opposed to compile time error. If I made a mistake, like with the misspelling of a major command, it just wouldn't compile. So in this case, I'm going to say we want to create a random value for answer. So let's just say int answer. If we give it a random value here, then every time we call play, it'll be the same answer. That's probably not ideal. And if we set the random value of answer when we run play, that's probably a better place to do it. And if we set the random value within inside of like the while loop here, then every single time it goes through the while loop, it's going to set it to a different number. And that's not what you want to do. That's kind of like what my little sister used to do when we would play this game. Like if I was getting close to the answer, she'd change the answer and she'd go, oh, no, that's not it. And I would be like, wait, you said it was too low last time. How can it be too high? So we don't want to do that. So we're going to change it once. So we declared it as answer. So we're going to say answer equals, and you're going to have to look this up. I only know this by heart because I'm old. So, okay, we're going to cast this to an int, right? We know that answer is an int. So we need to get an int out of math.random, but math.random is normally a double, so we're going to cast it to an int. So we're going to say math.random, okay? That gives us a number between 0 and almost 1, but not quite 1. We're going to multiply that by the number of values we want to get. So we want to get 10 values, okay? Math.random times 10 is going to give us 0 through 9 when you truncate the stuff after the decimal point, right? So what we want to do is add 1 to it. So that code is going to give you a random number that's going to be 1 through 10 inclusive, but not 0. And it'll only do it once because it does it, and then it enters the while loop, and then from that point on, it's going to loop within this while loop here. Okay, great. So let's go ahead and compile and run it again. Let's see what happens. That happens all the time. All right, so, okay. Guess number 2 1 and 10. 3, 2, what? Okay, so it said it's too high, but I guessed it. I can't be that good. Let me try it again. 3, too low. Okay. 2, 4, 5, 6, 7, 8, 9. So it almost works. There's just a puzzling error here. It shouldn't do this. It shouldn't say it's too high and then have me guess it. That's a little odd. So it has to do something with what happened through here. So this is where you have to think about, okay, if 3 is what it was, at some point, and here's where you have to think like a computer, what are the variables as we go through this? 3 was too high. So it shouldn't have done, let's see. Oh, this is why. This should be an else. I think that'll work. Okay. Because what was happening is checking one if, and then it was checking the other if. It was basically saying if it's too high, then print this. And then because this was an if, then it also said if it's too low, if it's lower, which it isn't, and then in that case say you guessed it and set the game 1 equal to true, which is wrong. So that's why it has to be if, if, and then else. And that's a good lesson for us to kind of figure out why it works that way. So that bug would have happened anytime we were too high. So 3, 4, so yeah, great. Okay, awesome. So that's the guess number program in a nutshell. If you want to go a little bit farther than that, I would challenge you to take the code that you've just put in and have it, when it tells you you've guessed it, have it also print out how many guesses it took you and have that be accurate. So it took you 3 guesses, it took you 2 guesses, whatever. So you're going to want to try to figure out how to do that code. And then ultimately the next step beyond this is to flip it so that the computer guesses and you think of the number from 1 to 10. And I think you can do that by just hacking this code, by changing the code a little bit. You can make that work. All right, good luck, and let me or Mr. Landgraf know if you have any questions.